To remind you, and I sent you an email out on this, Thursday and Friday you're going to be doing a worksheet that's due at the end of the period on Friday. It's pretty long. It's 5.1 through 5.4, so there's a lot of history in there. I suggest you get started on it, okay? Tonight maybe, take a look at it tonight, because it's due at the end of the period on Friday, okay? No excuses. Okay? You've got like 2 days to do that. Okay, integration of exponential functions. So here's the integration rule. E to the x dx equals e to the x. Need I explain this?
Yes.
Yes? It's a rule. You want me to explain 1 plus 1 is 2?
No.
It's a rule. Well, Henry, since you're so hella smart and since you're going to the best university in the world, can you explain to me? Huh?
Yeah. You hear about the suicides?
Yeah. Where, at Cal?
Yeah.
At Cal?
Yeah.
No, when I was there, there's a lot of smokeouts.
It was suicide last night.
Yeah. What happened? It was like gone through suicide test in like 1
No, that's not
What?
true.
Last night?
There was one last night?
Yeah.
But that's rare. Well, they're in the middle of finals right now. He did what?
I don't think a boxer.
Hold on. Why?
Well, because it's final week, so everyone's like, oh my god.
Well, it's nowhere near as bad as Cornell, though. Okay, Henry. Okay, Henry. Do you want to explain this rule?
Well, so if you differentiate.
See, that's why it's going there. See? Okay? Finish it, dude.
Yeah. Oh, yeah.
Yeah, come on, finish it.
Yeah, well, because the derivative of ex is ex. So the integration of ex is ex.
Okay? All right. So that's the rule. Let's do 4 examples and then we are done, okay? First example. Integral of e to the 2x dx. And after a while, you really won't do u sub, okay? It's going to be kind of all mental kind of process. So let me just go through the details of u sub. So you're going to let u is equal to 2x. So du is equal to 2 du dx. And so then dx is 1/2 du. Yes? So then this integral becomes e to the u. And in place of dx, I'm going to write 1/2 du, which gives me 1/2 e to the u plus c. And that gives me 1/2 e to the 2x plus c. Okay? So really, you can do this without u sub by noticing that what you can do is you can take this guy, okay, and then just divide by the derivative of the exponent. Okay, just divide by the derivative of the exponent, whatever the exponent happens to be. Okay? So you don't have to go through this long process here. Okay. But I think it'll take you a little while to kind of go on autopilot on that, so you might want to do u sub for a while until you see what the pattern is. Okay. All right. Second example. What do you want to u sub? X squared. So u is equal to x squared. So du equals 2x dx. Don't forget that part, okay? So notice here's your x dx. There's your x dx. So you want to replace that with 1/2 du. Is everybody okay on that? And then in place of e to the x squared, you're going to write e to the u. Integral of e to the u. E to the u. Yeah, and then next step you will replace this with x squared. Okay? Is all right on that? I'm glad you like math and that you're smiling there at the back. That's good to know. It makes my makes my day when people smile in my class. No suicides. Okay, next example is you. It's the same idea, people. It's the same idea. It's the same thing. Let me get the recorder on here. So then, let me get comfortable here. I mean, the rest of the time is going to be this lecture, okay, about where you can use this. Well, to be honest with you, wow, what?
I didn't mean offensively, like I'm asking.
No, I know. Hey, no offense taken. Okay?
I'm not being offensive though.
That's what I'm saying. Well, no offense taken at all, even if you're being offensive. All right, where would you use this? Well, let me tell you this, okay? Without that calculus, this would not exist.
No, I love
Okay?
I love the
Can you imagine your life without this? Can you imagine your life without this?
Why is the recorder on?
It is on.
You
may want to say what this is.
I'm really wondering at which applications would you use this. Like, I love.
I'll tell you honestly,
What jobs use this?
all engineering jobs.
So, like, in what-
All engineering jobs. All science jobs. Unfortunately, some economics jobs as well. Unfortunately. Yeah, because they're bullshit math in there. Okay? They're completely bullshit math in there. Okay?
I guess, again, I would say,
No.
what would you use this?
Any design of technology, okay? Anything at all, including even making this box here, I bet you there's a calculus gone in to design this. Because there's heat being generated in there. They're going to figure out how much heat is being generated. How are you going to dissipate it? All that requires calculus. All of it. Yeah. Sine and cosine, I mean, it's just, that's just a way of modeling data, right? So I'll tell you honestly, use, okay, so here's a use that I put of sine and cosine. I don't know if you guys are interested in this or not. But roughly, I'm going to be dating myself, but that's okay. I'm a dinosaur anyway. That's good. But I'm not an extinct dinosaur. That's the important thing. I'm not extinct. Okay, back in 1984, I was working for a company that had a contract with the Army. Okay, actually with the Marines, I think it was. And they had a project where they were trying to learn how to land a helicopter on a ship. Okay, on autopilot. So the ship is moving up and down like this. Okay, so we had to model the motion of the ocean. Okay, and what we did is we generated that model by adding a bunch of sine waves. So like sine 1t, sine 2t, sine 5t, sine 9t. Add them up. Get real-time data and see how we can tweak our model, okay? That whole thing went into this big-ass equation for controls of a helicopter to come and land without crashing. That all was super fancy calculus math, yeah. I mean, all the jobs that I've done in the 25 years that I've been in industry have all been with math. There's not a single day that I was not doing math. Okay, so it was all math. Okay, so it is used. It is used. So now that, Monica, you've been enlightened by math, come and show off your skills on this problem here. Okay, Henry, that question you get to send it. Haha. The clock's ticking. Okay, is everybody okay on that? Okay, one last problem and then we're done. Okay, same kind of stuff all over again. Okay, same stuff. Okay, U sub. What? The bottom. Okay, so U equals 1 plus e to the x. So du is equal to ex dx. So right here you can see is your ex dx. and you see it right there. Okay. This is a definite integral, so make sure we understand what the limits are for. So to begin with, what are these limits? What variable are these for? What variable? X. Okay, so notice that we're going to go to a u, right? Okay, so this integral is going to be equal to, and I'm not going to put my limits yet because I need those limits for the u variable. I don't want to really use that right now. Okay, so what do I have here? I have 1 over u du. Is everybody okay there? Yeah? And I'm not going to put my limits because I would really need to get my u limits. Let's not worry about it. We'll come back and fix that in a minute. Okay? What's integral 1 over u? ln abs u. Okay? I'm not going to put a plus c there because I'm going to put limits on it in a minute. Okay? So I know that there are limits here. I'm not going to bring in my u limits. Okay? But I know what u is equal to. Okay? So this becomes 1 plus e to the x. Now I can put my limits because what are they? What are they? 0 and 1. 0 at the bottom, 1 at the top. Okay? Is everybody okay? You chug this, what do you get? ln, you put 1 in there, you get 1 plus e. Is everybody okay? I'm putting x equals 1. Yes? Minus ln of 2. Okay? And can someone simplify using ln rules? Yeah?
1 plus e over 2.
Nice, good job. ln 1 plus e over 2 and cut them. Okay? Guys all right? John? Not okay? All right, I'm done. You guys have homework to do, and I'm telling you that worksheet is long. It's like 15 or 20 problems. It's due end of the day Friday, okay? And it's from 5-1 through 5-4. So get cracking on it and get cracking on this homework because come Monday I start 5-5. Yes? There's only one more test, and that's going to be on the 23rd, 4th? 24th of May. One more test. Sorry? Oh! Hey, no sweat, don't worry. You know I'm easy. You know I run Burger King. You know you can have it your way. It's a big deal. You want it after Memorial Day? Sure. You want it on the Tuesday after Memorial Day? You're not going to be partying on Memorial Day? Sorry? Okay. So Tuesday after Memorial Day? Okay. 5-1 through 5-5. The whole. Sorry? Yes.